So today we have force table experiment. So basically force table experiment allows us to add forces applied at different directions. So force is a vector quantity. So when we have two or more forces and when we need to add those forces, we cannot just add them like a scalar quantity. So for example, if you apply 50 Newton force to the west and 50 Newton force to the north, you cannot add 50 and 50 and call that 100 Newton force. So you need to apply the vector addition rule to add the forces because they involve not just the magnitude but also direction. Okay, so today we'll do an experiment to figure out how to find the resultant force. So for this we have this round object. So for this round object we'll be using this degree scale, this round degree scale. So put this at the center and we have this small wooden piece. You put this at the center of that round disc. Okay, and then you will use a bunch of paper clips to fix your this degree scale. Okay, so put one here and then the other one somewhere here and then other one somewhere here. So we have three pieces of these, and then we need to find a platform to put this over. So you can use anything for the platform. You can find a plastic box or something like this. Okay, so put this disc over some kind of a platform. Now, so you should have this ring with these strings and these hooks. So you will put this ring at the center of that, and then we'll be applying two forces at two different directions in this case, and then we'll find the resultant force in the third direction. So for the force we'll be using the weight, and for the weight we'll be using these sand in the bags. So I have two sand bags, each with 100 grams of sand. So I measure that using this digital scale. Now these are the forces that will be hanging on these hooks, and we'll have a fixed direction for the given forces. Okay, so we'll apply one force at 0 degrees. So we'll fix one force at 0 degrees. Actually, you can put this clip at 0 degrees. Where is our 0 degrees? So 0 degrees here. So you fix that here, and then we'll have our force, one of the forces at 0 degrees. So this middle one, let's call that 0 degree force, and then we'll hang the first force at 0 degrees. Again, it's not exactly at 0, so make sure your string goes through the 0 degree line. So you'll hang it here, that is 100 gram. And the next force, so you are given different degrees for the next force. So we have, if you look at the data table, the first angle is 40 degrees, so we'll use the second force at 40 degrees. So 40 degrees here. So move this string until this string aligns with 40 degrees. Okay, so make sure it's going through the 40 degree angle, and then you move this paper clip so that it's centered at 40 degrees. Okay, so you move this through 40 degree angle, and if it is not going through 40 degrees you can move the string to the left or to the right so that it's exactly going through 40 degrees. Okay, now you hang this 100 gram over that. So we have 100 gram going through 0 degrees and 100 gram force going through 40 degrees. Okay, so here we are measuring force in terms of gram. So usually we measure force in terms of Newton. We can convert this gram to Newton, or we can just use the unit of gram force. Okay, if we don't want to convert, because it's just the conversion factor. So instead of converting the gram to Newton, we can just call gram as gram force. So now we need to apply some force on this side. So we want to have equilibrium between the forces here and the resultant force so that we can find the resultant force. So We'll be pulling this on this side, and make sure when you're pulling they are still aligned at 0 degrees. So here this is not 0, so you need to move it so that it's going through 0 mark, 0 line, and this one needs to be 40. So when I pull it, it's shifted, so you need to shift it until it's 40. So make sure they are exactly at the degrees that we intend. So now this is the force we need on this side. Okay, so you put this paper clip in that orientation. So move this, so pull this until you get the equilibrium. So this is the equilibrium. Now we need to add some weight on this hook until you will see the equilibrium position. So if I add this much force, it's not in equilibrium. If I add this much, it's not in equilibrium. So this wooden piece needs to be exactly at the center of this ring. So that means when this wooden piece is exactly at the center of the ring, then this is in equilibrium. So also you need to make sure that it's at the center by moving this right or left. Okay? So if it is not at equilibrium, then it will not be at the center. So about there, and still 0 and 40 degrees. Now you start adding the weight on this side. So I'm going to use another plastic bag. So I will need to measure, put some sand on this. Start with some, maybe we know that the resultant would be more than 100, so we'll start with 100 gram, or let's say 120 gram, and then gradually add more and more sand. Okay, so I'm gonna put some sand. So we have this spoon, so with that spoon you can add sand. If you don't have sand, you can also use salt or some small pieces of rock. Okay, so because this is the experiment that you are doing at home, so you need to be a little bit more creative. So if you don't have something, then you can think about the alternatives. So now I'll hang one side of this bag so that I can add more if I need. So I'll hang this like that. So it's not enough, looks like it's not balancing, so that means I need to add more. So I'm going to add more sand, add more, and then add more, and then once you add that, so you can pull it slightly, see if it's in equilibrium. It's still not in equilibrium, so you need to add more. So add more, and make sure you put a paper or something underneath so that you can later collect the sand easily, so that it doesn't mess up your table. So I'm going to add more. So pull it again. So now it seems like it's now in equilibrium. We need to remove a little bit of sand. Seems like it's slightly more than what we need. So just add, or just remove a little bit. Seems like now it's more or less equilibrium. Okay, you need to move away from or towards the center, and see, it's more or less equilibrium. Okay, so I think it's still not exactly in the center, so that means we may need to move this slightly away or towards the certain angle. So make sure that this ring is exactly at the center. So see, it's more or less at the center now. So this is displaced, so make sure this doesn't get displaced. Okay, so you need to move it at 40, and this should be at 0, and then move it to the right or to the left so that it's exactly at the center. So here, so it's almost at the center, or it's exactly at the center right now. So now we need to measure the angle, so angle as well as the weight that we added. So here our angle is 200 degrees. Okay, so you need to note that down. For the first force of 100 gram at 0 degrees and second force of 100 gram at 40 degrees, our resultant is certain force at 99 degrees. So our resultant is at 199 degrees. And now let's measure the weight of this. So we have this measuring scale. So turn it, oops. So turn it on, and then remove this for a second. Now let's measure that. So make sure it's initially 0, and make sure there's nothing on the floor. So you can close this so that it doesn't spill. Okay, so measure that. So it's 183 gram. Okay, so our resultant force is 183 grams. So the angle is 199 degrees and the net is 183 gram. We'll call this gram force. Okay. So our first force is 100 gram. Second is also 100 grams. Second is at 40 degrees, and that's that. So this is the resultant. Now, this is the resultant on the other side, right? If we want to add these two forces, the resultant should be on the same side. So we are getting this to balance the resultant of these two forces. So the resultant of these two forces is in between the two forces. So we are applying one force at 0 degrees and other at 40 degrees. So the resultant should be somewhere in between. That's the F net. But we are applying the force to balance this force. Okay, this is the balance force. If we want to find this net force, the magnitude would be same as the balance force, but the angle needs to be, it's if we measure from this side, then it will be this total angle minus 180 degrees. If I have 199 degrees, then I need to subtract 180 degrees from that to get this angle for the resultant, or F net. Okay, so actual angle would be 199 degrees minus 180 degrees, which would be 19 degrees. So that's angle made by the resultant force with our 0 mark. So that's one trial. So now you will be using different weights at different angles and do the same kind of process to find the resultant force and resultant angle.